Welcome to our channel Biswanka's Math Exclusive. This is my part 3 video on topology. Now start with limit point. Let A be a non-empty set in a topology space x tau. An element P of x is called a limit point. Of A not equal to phi if every np of P meets A at a point other than P, that is np intersection A minus P not equals to phi. If P is not a limit point, then P is called isolated point of A. In this case, NP intersection A minus P equals to phi. Now an example. X equals to A, B, C, D, E and tau equals to phi, B, D, E, B, D, E, X, A, C, D, E. Find limit points of A, B, C, D. NA equals to A, C, D, E and X contains CD other than AE. So A is limit point of A. Now NB equals to B, B, D, E, X, not a limit point. NC equals to A, C, D, E and X. So C is limit point of A as this contains D other than C. Now ND equals to DE, BDE, ACDE and X contains no element of A other than D. So D is not a limit point of A. Now NE, DE, BDE, ACDE, X contains D other than E. So E is limit point of A. Thus A dash equals to ACE, set of all limit points. Next, tau NBD. Let x tau be a topological space and let x belongs to capital X, then a subset N of X is called a tau NBD of X if there exists a tau open set G such that X belongs to G subset N. Here is an example that X equals to ABCD and tau equals to X phi A, AB and ABD. Find NA and NB. NA equals to A, AB, ABD and X equals to tau NBD of A. A belongs to A subset X equals to N, A belongs to AB subset X and A belongs to ABD subset X, A belongs to X subset X and NB equals to X, AB, ABD. Next, closure of a set in x tau. Let A be a subset of X where x tau is a topological space, then the intersection of all tau closed subsets of X which contains A, that is superset of A, is called closure of A and is denoted by A bar. Here is an example that X equals to ABCD and tau equals to this equals to family of tau open sets, then the closed subset of X are X, BCD, AD, BC, D and phi are tau closed subsets of X. The closure of B is B bar equals to intersection super tau closed sets of B equals to intersection X BCD BC equals to BC, that is B bar equals to BC. The closure of AB equals to intersection super tau closed sets of AB equals to intersection X, that is X, that is AB bar equals to X. That is the closure of BCD is BCD bar equals to intersection super subsets of BCD equals to intersection BCD X equals to BCD. Next example, if A equals to open unit interval 0, 1 of reals with usual topology, we find its closure A bar equals to closed interval 0, 1 which is a closed set. Closure of A is A bar equals to closed interval 0, 1. Next a theory. Proof that A union B whole bar equals to A bar union B bar. We have A subset A union B, B subset A union B implies A bar subset A union B bar and B bar subset A union B bar implies A bar union B bar subset A union B bar. Again A bar and B bar, A bar union B bar of two closed sets A bar and B bar is also tau closed sets. Further, A subsets A bar, B subset B bar implies A union B subset A bar union B bar subset A union B whole bar by 1. This is 1. Hence we observe that A bar union B bar is a closed set containing A union B, but A union B whole bar is the smallest tau closed set containing A union B, that is A union B whole bar subset A bar union B bar. This is 2. From 1 and 2 we get A union B whole bar equals to A bar union B bar. Proved. So here is my today's topic, and if you find this video is helpful for you, please like, share and subscribe our channel. Thank you.